Okay, class 7. This lesson 1.2, reading binary numbers. In this lesson, you will learn about bytes. You will learn about bits and bytes, how to convert binary numbers into decimal numbers, the meaning of base 2 and base 10, understanding binary numbers. We have to keep in our mind very important thing, that's base 10 and base 2. Base 10 means decimal number. Why we call it base 10? Because it has 10 digits number. 10 digits numbers. Okay. Base 2, that's a binary number. And why we call it base 2? Because binary number only has 2 digit numbers, the 0 or 1. Do not mix. Okay, you can convert a number like from decimal to binary, and the number will be around about 4 5 3 2 or whatever, okay, digit numbers, but you cannot represent that number. You cannot represent it with more than 0 or 1. That means you cannot use any other numbers apart from 0 and 1. Okay, so base 10 is a decimal number, base 2 is binary number. In the last lesson, you learned that a computer must store everything it processes as digital data. You learned that computer use a binary number system to understand what digital data looks like. You also compare some binary numbers to decimal numbers. We took an example and we took also an exercise last class how to convert the numbers. As we said, the decimal number system uses 10 digits. 0 to 9 do not include 10. Why? Because we said 10 it's representative of 1 and 0, which are included on the numbers from 0 to 9. The value of each column in a decimal number is 10 times greater than previous column. This is very important. That means what? The column number 1, okay, and the column number 2. So the column number 2 will be greater by 10 times than the previous column. How is that? Look over here, for example, okay, this system, this decimal number base 10. Usually we will use to convert the numbers from right to left. Do not start from left to right. You have to start from right to left on the column. For example, look here, 3 4 5. Okay, 3 4 5 2. That is a digital numbers. Sorry, that is a decimal number. Okay, there is decimal number 3 4 5 2. It's written like this. 3 units. Look here, 4 units. What he did, multiply by 10. That is 10 system. Multiply by 10 will be 100 system. Multiply by 10 will be 1000 systems. Okay. Base 2, 0 and 1. Base 2 means multiply by 2. Okay. Look over here. Very easy. Base 2 means multiply by 2. The number is like this, 10110. From this column to this column, you have to multiply by 2. It will be 2 second. Okay, multiply by 2, 4 second. Multiply by 2, 10 seconds. Okay, now over here, okay, we are having something called octal number. The octal number based on 8 number system. 8 number system, that is octal number. Okay, so right now we are having around about 3 systems or 3 number systems, which is binary, decimal, and octal. Binary multiply by 2, decimal multiply by 10, and octal multiply by 8. Okay, very easy. Okay, now we are going to see, sorry, now we are going to see how we can multiply or how we can convert from those systems numbers. Okay, so this is octal number. Okay, now there is questions, easy questions. How many digits does the base 8 system use, and what are those digits, and what are the value of the first column in the base 8 number system? Draw a table to show your answer. Okay, we are going to solve this activity, okay, together, but let me explain something for you, and after that we will get back to the activities. Move to page number move to page number 12. Okay, we are having bits and bytes. Okay, bits and bytes. Each digit each digit in a binary number is called a bit. There is difference between bit and bytes. From where the name of bit, from where they took the name of the bit from the binary digit. They took the B letter from the binary starting, and it from the end of the digital word. So combine both together, it's a bit number. Okay, it's a bit number. A byte isn't very useful on its own. It can only store one or two value. You have to keep this also in your mind, very important. On a byte, on a bit, you cannot store more than 0 or 1. It can hold only 0 or 1. Make a binary more useful. Computers group bytes together. That means the computer used to take a group of bits together, and after that, okay, will transfer it to hold more digit numbers, and in that case we will call it bytes. Okay, see, bytes, you can store a number of binary digits, but on bit you cannot store more than 0 or 1. Okay, whatever the number is, you can store it in a byte, in a bytes. Okay, but on a bit you cannot store more than 0 and 1. Now look here, we have something called the language number. What is the language number? For example, 11. We are going to take the number 11. Okay, the number 11. The number 11, if you are going to read the number 11 using the binary number, what you will say? 1 1. You will not say 11. But when you are going to read the number 11 on the decimal system, you will say 11. Right? See, it's quite different. Okay, decimal system, that is 11. Binary system, it's 1 1. Okay, so we took, let us make some conclusions. Okay, we took the binary system, we took the decimal system, we took the octal system, and moreover, we came to know the bits and the bytes. Okay, and how we can read the binary numbers, and also how we can convert from binary to decimal. Okay, so today we will see how to convert from binary to octal, and we came to know binary base 2 and decimal base 10 and octal base 8, and we came to know while converting a number with binary, that means we have to multiply by 2. If we want to convert a number with decimal, that means we have to multiply by 10. And if we want to convert a number octal number, that means we have to multiply by 8. And we came to know also bits, or one bit can hold only 0 or 1. And we came to know that is bit, from where they get the name bit, from the binary digits. They took the B letter from binary, and they took the IT from the end of the word digital. Okay, this is a conclusion of our class today. Okay.